Hello world! So in this first try to process reality, I would like to address my core concern, I guess, that I have at the moment. And this is our connection to the world. I think in this time, many of us feel that we could feel more connected to the world. So I think this loneliness feeling of being like cut off from the rest of the world, this is really important to address. So without further ado, I think I'll jump just straight in. I'm a physicist, so I was trained in our Western natural sciences, but I am also a martial artist, and so I have some experience of Eastern way of looking at the world. And recently I was introduced to a philosopher, scientist, mathematical physicist turned philosopher called Alfred North Whitehead, who lived at the beginning of the century and was a contemporary of the changes in physics from what we call classical physics to what we now call modern physics, even though by now it's more than 100 years old, right? So meaning especially quantum mechanics and general relativity. And he developed a framework, what's called a metaphysics, to understand, to make sense of these changes in our physical understanding of the world. Something, actually, that I was taught at university that did not exist. So I was taught that there is no metaphysical framework for quantum mechanics. I was taught in the spirit of physicist Richard Feynman, who famously said that in regards to trying to understand quantum mechanics, we should just shut up and calculate. Meaning that we could treat quantum mechanics as a set of weird rules of calculations that if we feed in if we feed in the state of a system and we just calculate according to these weird rules, what should come out, that prediction actually fits the measured outcome of the system extremely precisely. So that was fine for him, and that was still fine apparently for the professors at university that taught me. So we treated quantum mechanics as these weird sets of calculations using complex numbers that, if then again reduced to its real parts, could be interpreted as position, momentum of a particle, and we would then find a particle sort of there with sort of that velocity and momentum. As you might know, those two quantities cannot be known exactly at the same time. There's this Heisenberg uncertainty limitation for those two parameters. But if we would know those positions in phase space, we could then again calculate for the future. And this disturbed me quite a bit. So what I do want to talk about really is Whitehead's approach, Whitehead's interpretation of quantum mechanics and what it actually does tell us about the world. So not treating quantum mechanics as something that we can just calculate future states from, but something that actually tells us something about how the world is, or maybe even more precisely, how we can understand the world. So I think there's an important distinction there to be made. I think, and I'll probably make another video about that, our natural sciences do not tell us anything about how the world actually is. What they do tell us is how we can make sense of the world. And how do they do that? They provide stories that, if we assume they are correct, then we can use those stories to predict something about the future. For example, Newtonian physics assumes that there is something that we call forces. So if there's an object and we assume there's a force that the Earth is acting upon this object, and therefore this object accelerates according to the force proportional to its mass. So we have F equal ma. If we assume that is correct, then we can predict the acceleration of that object, and we can also measure it, and those two agree quite well. So we assume that that statement, F equals m times a, is a good statement about the world. It's not proven to be correct. Nothing in science is ever proven to be correct. All we can do in science is prove that some idea about the world was incorrect, which we did for Newtonian gravity, for example, right? And we replaced that simple view of Newton with a more elaborate view by Einstein. And so it's a more complicated, more elaborate story about the world that helps to explain things even more precisely than the story that we had before. Nevertheless, we always know that our stories aren't the final thing. They do not talk about how the world actually is. They talk about a story that we can tell ourselves about the world, that if we assume it to be correct, we don't make a huge mistake. So, back to Whitehead. The story he came up with, I think, is a very fascinating one because it uses words that have a very broad applicability. So they can be the same words that he uses to describe quantum mechanical processes can be applied to our everyday lives. They can be applied to stars. They can be applied to galaxies. So the words themselves do not make any reference, as far as I know. Please correct me if there's any Whitehead scholars in the audience. But as far as I know, Whitehead's scheme, his organic philosophy, does not make any reference to specific scales. And this to me is extremely important. I'll come back to that again at some point. So what's the actual story he tells us about the world? He says, let's think about the world as if it was composed not of objects in a space-time moving about, but let's talk about the world as if it was instead composed of moments in which something happens. Okay. Well, yeah, we can certainly think about moments. We are probably still compelled to think about moments in which some object actually hits, for example, another object, and that's something that happens. Yeah, exactly. That could be something that happens in a moment. That could be an actual occasion, which is the word that he uses for moment, is an actual occasion. Something actually happened. And so what actually happened? Well, it could also be just the moment of now. Me realizing that I am talking about a moment. You watching this, realizing that you are watching me. And I don't know, maybe you had this experience that before I mentioned you as being actually you could watch me and sort of forget about yourself for a moment or two. Right? It happens to me, at least, constantly. If I watch movies, I completely forget I exist. I'm just sort of absorbed into that movie. And it happens again and again. If I concentrate on something, really, I do not think about my own thinking. I am not a Cartesian mind constantly thinking, therefore knowing that I am. I actually just am in a thought out there, probably. For example, doing some calculations if I solve some physical problems, or actually being immersed in the moment of watching a sunset, or just in the feeling of somebody else who talks about their emotions to me, for example. I I get absorbed in those moments, and I'm not constantly knowing that I, as a mind, exist looking at objects in the world. That's not how I experience the world. And so the idea that, yeah, actually my everyday life is sort of composed of moments of realization of something's happening, and they're sort of unclear in timeliness, in duration, I mean, right? It's a moment can be very brief and short. Something happens just now and it's gone in the next second. Or it can be a long moment, right? A moment can stretch for quite a while. So I like this word because it fits with my actual experience of everyday life. Okay, that's fine. But you were talking about science before, you say. Well, yeah. And I was talking specifically about quantum mechanics. So let's go back to that. Let's examine that black box that Feynman uses to put states in and get states out. And let's examine a little bit what's inside the box. It's not a dead cat that's inside that box, actually. It's dead and alive. No. So what I do want to talk about is how does quantum mechanical calculations actually proceed, right? So you do put in a state, which is most simply composed of, for example, a position and a energy of that, let's say, a electron, which is sort of the archetypical quantum mechanical object. So you have an electron, let's say in free space, at some position with some momentum, let's say even that we know of, sort of, according to Heisenberg's uncertainty principle, but we know, let's say, its energy extremely precisely. Let's assume we have some numbers, some real numbers that describe the state of this electron. What happens then? The idea is the electron is a point particle, right? So it has no extension whatsoever. It's a mathematical point at that moment. But then what happens in the box? So as soon as you start sort of the quantum mechanical clock, it's no longer a point. It's a probability wave, right? It's not even a probability wave. It's a complex numbered wave. And only if you square the amplitude of that wave, of that complex numbered wave, you get back a real number, and you can interpret that real number as a probability of finding that particle at that particular point in space and time. So the wave itself is complex numbered, and I think that's fairly important actually, because complex numbers are not real. And so why not treat it as reality in that space in between? So what hold on. This is gibberish, I know. So let's try and make things clear again. So we have a particle, a point here. It's, let's say, we emit a electron from a very, very tiny needle that we charge. Let's say we have this setup, right? We have a needle here, very, very, very tiny needle, metal plate at the other end, somewhere over here. And then we apply a voltage from needle to plate. So the plate is positively charged, the needle is negatively charged, so there's lots of electrons in the needle. There's a sort of vacuum of electrons in the plate, so there's too little electrons in the plate. So the electrons from the needle really, really need to get to the plate. That's the idea, right, of this voltage. So what do the electrons do? They are emitted from the needle and they soar through. Let's say there's a vacuum in between, right? We have this in a vacuum chamber, so very controlled environment. So almost no air molecules in between, so the electrons can just shoot straight to the metal plate. Perfect. So where on the metal plate will they hit? So let's assume we can put, it's quite easy. We can put a screen in front of the metal plate, which lights up when an electron hits it, and we can even have some apparatus that remembers all the points, and we can get distribution of where the electrons hit. What do we actually have here? We have electrons leaving the tip. We have electrons hitting the plate. These are called measurements in quantum mechanics, right? We have the first measurement at the tip, This is sort of our input state into the black box of calculating quantum mechanics. Then we have a measurement at the plate, where we know where the electron is. And in both cases, the electron is actually not a wave, it's a particle. But where does the wave come in? The distribution on the metal plate looks just like the pattern a wave would make if emitted from the tip. And we can put all sorts of complicated things in between, right? We can, for example, put a double slit in between where the electron has to pass through either this or that slit, or, right, if it was a wave, it could pass through both of them at the same time. And then it would make what we call an interference pattern. The wave, right? The wave would make an interference pattern at the screen. And what do we see when we shoot electrons? We see the interference pattern as if the electron on its way to the plate was a wave, right? That's sort of the idea of this quantum mechanical particle wave duality. It's sort of a particle whenever we look at it, but there's something wave-like in its propagation. Now, the, I think, ingenious way of talking about this of Whitehead is that it says, well, what we actually have are moments that in physics we call measurements. Those are real. And in between, we do not call this actual reality. And also in physics, we use complex numbers, which are not real, to describe this process. That fits to me quite well. Okay. But that's nothing new. That doesn't add anything to quantum mechanics. That's just a weird sort of way of treating the in-between as actually non-real. Why would you do that, right? So here's the thing. Quantum mechanics as a theory sort of actually only is the black box. It's not the input. We have to provide that to quantum mechanics. And it's not the output. There's no mechanism in quantum mechanics that makes this change from the complex numbered wave to the real particle. This is called the collapse of the wave function. Right? The idea is that you have this spread out wave and it collapses boom, into a particle. Why? Nobody knows. Okay. There's a few different interpretations. The many worlds interpretation tries to be one, even though I really don't get how this can be a viable option. The idea there being that from this continuous wave of this one single electron that we shot out of the needle towards this metal plate, there's a continuous wave in 3D space. And the idea of the many world interpretation is, well, actually, the waveform collapses into continuously every single point in 3D space in one universe. It branches off continuously many, infinitely many new universes for actually every single electron in existence. At every single moment in time, the universe branches into infinitely many new universes. And we just happen to live in one of them randomly. There's no explanation in which universe our consciousness resides in, as far as I know. I'm not an expert in the many worlds interpretation of quantum mechanics. You might have gathered I don't really think it's a viable interpretation at all. I think it's extremely childish. It's basically just giving up on the problem and saying there is no problem. Well, yeah, there is. There is a problem. Quantum mechanics does not have a mechanism for collapsing the wave function. There's the probably oldest Copenhagener interpretation, which, again, consciousness comes into the picture, says, well, if an observer looks at the measurement, then the waveform collapses spontaneously because of the interaction of mind and quantum mechanical matter that makes it real. So what actually makes the world real in the Copenhagener interpretation is our consciousness. So the world is not real until somebody looks at it. And this is where, again, we come back to our friend Whitehead, because he set out to heal this split. To heal this split between our consciousness, our experience, our feeling of reality of the world and the world. So again, What was his contribution? You remember? He said, let's think about moments. So moments have an inherent quality to them. I described the moment of looking at the sunset, right? So that's a moment in which something happens. And again, the words themselves, the moment in which something happens, makes it apparent that definitely there almost has to be a qualitative acknowledgement, sort of at least, of the thing happening. Without that, it's difficult to say that there's an isolated moment happening. If it's not happening to anybody, how should we ascribe this, yeah, that's real status to it if nobody knows about it? Is it real? So that's the ingenious wording that he uses that really drives the message home that if something is happening, it sort of already brings together these two seemingly separated spheres of something that is happening to someone, right? So there needs to be an objective as well as a subjective side of this moment. And that's exactly how he then goes on describing these moments or these actual occasions that happen, the actual happening, in more detail. So the way he talks about an actual occasion almost as an individual, and he calls it even a organism. So hold on, let me explain. So how does a moment come to be for Whitehead? His idea is the moment gathers itself together. And the word that he uses is concrescence. So the moment sort of solidifies into being. Where does it solidify from? Well, from the past, from past moments. So past moments sort of pass on their being to the future. And from that past, the new moment to be inherits information, let's say, and it brings that information together and it sort of condenses it and it brings it together until it's something actually new. And that's where the moment, actually happens. And actually almost sort of realizes itself, right? So there's a self-realization. It brings itself together and it makes itself real. And then it perishes immediately into what Whitehead calls objective immortality, meaning it became subjectively aware of it being there and then becoming an object to the future to be inherited. Does that make sense? I'm not sure if I make sense. But then, the point that I actually set out to explain, I didn't even touch, right? Which was our connection to the world, if you remember. And why did I talk about quantum mechanics then? Here's the point. Again, back to this ingenious way of talking about moments, of actual occasions, actual entities, he calls them, to drive the point home that this is what actually exists. These moments of existence, the moments of experience, we'll come to that in a second, that these moments are actually real. I think they can be very nicely translated to quantum mechanics as measurement points. So you have an actual occasion of an electron leaving the tip of this needle. You have the actual occasion of the electron hitting the plate. Now, again, in quantum mechanics, this is sort of a miracle that there's an actual real measurement happening at the plate. Because in between, we have quantum mechanics and there's no mechanism to make it real. Now, in Whitehead's words, there is. He actually describes the mechanism in quite some detail. The mechanism is concrescence. The electron leaving the tip is an actual occasion. It perishes. There's no actual electron traveling through the air. What is then traveling? The information of there was an electron that left the tip. Exactly as in quantum mechanics, where there's only a complex numbered wave traveling. There's something immaterial, something ungraspable, English, I don't know, traveling in Whitehead's scheme, which is that which is inherited by the next occasion, the electron hitting the plate. How then does the electron know where to hit the plate? This is where something interesting comes into play. Freedom. The electron isn't free. It can't go backwards. No. It's constrained by exactly the quantum mechanical wave description, by the past. So the past limits the possible futures, but there's still a range of possibilities that's open to the electron. And in Whitehead's scheme, the one that actually does the choosing is the electron itself. So that's probably weird. Again, I say it again. The electron leaving the tip deterministically determines a spectrum of possible outcomes of the future. They have a range of probabilities as described by the quantum mechanical wave squared, interpreted as a probability distribution. But now comes the ingenious part. The electron, out of this list of probable outcomes, restricted by the probability of the outcomes, has a certain degree then, this exact certain degree, of freedom to choose its actual position of hitting the plate. So it can determine its own occurrence, where to materialize, where to manifest, where to collapse to. So suddenly, right, you see, the electron is a subject choosing its own place, choosing where to be. And it's not the same electron per se, it's different moments. One moment, electron leaves the tip, that's actually real. One moment, electron hits the screen, that's actually real. Those are two moments. There wasn't a moment of that electron being passed to this place per se. We can put some measurement device in between, and then we'll have a moment that's actually real. Also for the electron, because there's an interaction. You see, the reality of the moment for the electron, the possibility for the electron to manifest itself, is only given as interaction with something else. So the electron does not exist by itself. The electron only exists by virtue of interaction with something else. Is that true? I'm not sure. Maybe correct me again, Whitehead scholars. Would you say, is it possible for an actual occasion to exist as itself without interaction with anything else? Comment below, I guess. I'm not sure. You might have gathered the intent of this channel, if it actually grows into a channel, is to process reality, meaning I'm gonna be in the process of trying to work through these ideas, and I'll talk out loud. And I hope you participate in my journey of processing reality. For the Whitehead scholars out there, you might have noticed it's a little pun intended upon the the title of Whitehead's book, right? Process and Reality. I think it fits very well, this idea of this channel being a series of episodes, actual videos, occasionally coming out describing the process of me going through this process of understanding reality, which I'm very much trying to. This is sort of my life. I studied physics because I wanted to understand reality. I also studied martial arts because I wanted to know what is really possible and what is not. So what does this have to do with our connection to the world? I think it does a brilliant job of healing this split between consciousness and a objective dead world, of a material world that is at best, at some points, maybe in like humans, with spirit, with mind, and with consciousness, with conscious experience. All the rest is just matter, no consciousness, no spark of realization of something's happening. Maybe biology, maybe some species also possess this spark. Maybe. That's really sad, I think, that way of looking at the world. And it distances us, humans, who have this weird consciousness, from everything else. So at best, we can relate to maybe dogs who maybe because they spend so much time with us humans also almost be something like conscious, according to some philosophers. Well, according to some philosophers, we even don't have a consciousness, right? It's just an illusion. We even are like zombies. Again, another point of view that I don't understand how it could be held consciously. Well, back to Whitehead. On the other hand, Lau, let's think about this. If even electrons, the most fundamental of particles, as we call them, determine their existence themselves, they choose where to hit the plate, in line with certain probabilities, in line with certain limitations. Well, that's actually exactly how I experience my own freedom. I am not free to float about. I am not free to vanish and reappear somewhere else. I have limitations, severe limitations. But within certain bounds, there's a bit of a freedom to wiggle. We have some wiggle room. We can even choose to just follow the mainstream option of most likely trajectory through our lives, accept the inherited way forward. We can go and continue, business as usual, not thinking about it too much. We can also be rebellious about things. We can be outside the pack. We can be at the edge of the probability curve, do something weird, do something unexpected. We have that freedom. We can choose. We can actually choose to change the way the world works. We can actually change a lot. And I'll probably have to argue in a later video exactly how much we can change. And I think we have a far greater ability to instigate change than most of us realize. But back to the main theme of connection. So if even electrons have this same ability to choose their moment of existence, how they are at that moment. For them, that mostly means where they are. As we have the same ability to choose how we are at any given moment. There's no qualitative distinction between me and all the electrons around me and everything in between, right? So the same thing is true for a shoe, right? The shoe is there. Now I see it. Then it inherits this position, this way of being into the next moment. And, shoe's probability distribution is quite narrow. Not much wiggle room. It's still there when I look at it again. Yeah, I can try to be like a rock at the point, but nah. It's like me trying to float. It's not going to happen. But again, it still is choosing exactly how it is. According to quantum physics, right? There's a whole sea of entangled wave functions going on down there. And they all have to collapse again into actually being a shoe. So in Whitehead's framework, there's a sort of, let's say, pre-conscious. There's not a consciousness at that level, even not in Whitehead's framework. But there's a qualitative part of decision-making happening, of realization, of self-realization of that shoe being there. The same is true for cells, for plants, for birds, for animals. At all scales. The same is true for humans, the same is true for our society, which we are a collection of individuals. But again, the society chooses certain ways of being that sort of goes beyond what individuals choose. You can certainly use those words. You can describe how societies interact with one another as if they were single beings. Oh yeah, that's exactly in line with Whitehead's theory. You can use the same words also for bigger scales, The planet, you can talk about the planet as Gaia, there's a theory, right? It works. You can use it with certain limitations, probably, right? To describe how it behaves. And so what does that mean? That means there's no qualitative distinction between me experiencing the world as a series of moments in which I realize myself of who I am, where I am, what I am, how I am. I have limitations, but I can choose within those limitations. That's exactly the same thing that everything else in the universe behaves. So I can empathize, I can have empathy with everything in the universe now in this framework. That's wonderful to me. I can feel, with certain limitations, empathy for that shoe down there. But I can definitely feel empathy for a plant. I can definitely feel empathy for the bird or for another human being. Or I can feel empathy for the world at large. And I think that is why I find Whitehead's framework so appealing, so wonderful, and so needed for the future of our world. Thanks for listening, if you were. And I hope to see you again for another occasion. At another occasion, I don't know. Goodbye, world. Goodbye.